Welcome back. In continuation to the previous lecture, we will solve a couple of problems on viscosity. So this is the problem statement that is given to us. Calculate the dynamic viscosity of oil, which is used for lubrication between a square plate of size 0.8 by 0.8 meter and an inclined plate with an angle of inclination 30 degrees, as shown in figure. The weight of the square plate is 300 Newton and it slides down the inclined plane with a uniform velocity of 0.3 meter per second. The thickness of the oil film is 1.5 mm. Okay. So now if you look at the diagram that is given to us, so we have got two plates. So this is the inclined plate, which is stationary. And this is the moving plate that is sliding with the velocity u equal to 0.3 meter per second. So if we write down the given details, so we have got u, so that is 0.3 meter per second. And if you look at the thickness that is given, so that can be taken as y, and we can write that as 1.5 mm. So if you convert that to meters, that is going to be equal to 0.0015 meters. Okay. What else is given is the weight of the plate, and it is acting in the downward direction, that is at 300 newtons. Okay. But what we are interested is what will be the weight of this inclined direction, that is at 30 degrees. Okay, so we have to find the horizontal component of this particular W equal to 300 Newton. So we can, so the horizontal component for this particular plate, that is going to be F is equal to 300 cos 30. So cos 30 is cos 0 is 1. So cos 30 is 1 by 2. So 300 into 1 by 2, that is going to be equal to 150 newtons. So this guy is 300 into 1 by 2. So that gives us 150 Newton over here. So that is your F. And they has given you the area of the plate as well. Area of the plate is 0.8 by 0.8 meters squared. So 0.8 by 0.8 is 0.64 meters squared. So that is the area. And what they want us to find out is what is the dynamic viscosity of the oil. So they want us to find out the value of mu. So what we know is, we know the equation tau is equal to mu times du by dy. Okay, or we can say mu times u by y. Okay, so now what we have got is we need to rearrange the equation and write it as tau times u y by u. So we need to find out the value of tau. So tau is shear stress. Shear stress is nothing but force by area. So that is why we need to find out the force with which this particular inclined plane slides down. So that is why we took the horizontal component of this particular W equal to 300 newtons. So your F is 150 and area is 0.64. So that would give you the value in Newton per meter squared. And then if we substitute the values over here, tau times y by u. So let me take it as such, 150 by 0.64. The value of y is how much? It is 0.0015. And the value of velocity is 0.3. So let me use the calculator over here. So that is 150 into 0.0015 divided by 0.64 divided by 0.3. That gives us 1.172. So that is 1.172 Newton second per meter square. Isn't it? The value of tau is Newton per meter squared. Y is in meter, and then you have got meter per second. So you have got Newton second per meter squared. So this is the final value that we get. So it is 1.172 Newton second per meter squared. Okay. So let's move on to the next problem. So here they have said there are two horizontal plates which are placed 1.25 centimeter apart. The space between them being filled with oil of viscosity 14 poises. Calculate the shear stress in oil if the upper plate is moved with a velocity of 2.5 meter per second. So we have got two plates. So we have got the upper plate, and they have said this upper plate is moved with a velocity of 2.5 meter per second. And then there is a lower plate. This lower plate is fixed. And so that is indicated with this hatched line over here. So this is your upper plate. This is the lower plate. And the statement says that they are 1.25 centimeters apart. So the distance between the two plates is 1.25 meter, and they have given you the value of the viscosity, which is 14 poises. So if we write down the given details over here, so we have already said U is 2.5 meter per second and Y is 1.25 centimeter, which can be written in meters, 0.0125 meters. And the value of the viscosity that is given as 14 poises. So we have to divide it by 10 to convert it to Newton second per meter square. So that is 1.4 Newton second per meter squared. Okay, so these are the details that are given to us, and they want us to find out the value of the shear stress. Okay, so which means we can once again use the relation tau is mu times du by dy, which can be written as u divided by y. The value of mu is 1.4. The value of the velocity is 2.5, and the distance of separation is 0.0125. Okay, so that should give us the value of tau. So let me use the calculator and see what we get over here. So that is 1.4 into 2.5 all divided by 0.0125. So that is 280 Newton per meter squared. So that is the value of the shear stress that we get for this particular problem. Okay. So now the next problem. The space between the two square flat parallel plates is filled with oil. Each side of the plate is 60 centimeter. The thickness of the oil film is 12.5 mm. The upper plate moves at 2.5 meter per second, and it requires a force of 98.1 to maintain the speed. Determine the dynamic viscosity in oil, and they also want us to find out the kinematic viscosity. So let's draw a diagram for this first. So we have got two plates. They have said that the upper plate moves at 2.5 meter per second. The lower plate is fixed. Only the upper plate is moving. And they have said that this space is occupied by oil. And we are supposed to find out the value of the dynamic viscosity for this, as well as the kinematic viscosity of this particular oil. Okay. And what they have said is the force that is applied to move this plate is 98.1 Newton. They have said that each side of the plate is 60 centimeter. So the length of the plate that is going to be 0.6 meters. And the thickness of the oil film. So this thickness of the oil film that is given as Y, which is 12.5 mm. So we can write this as 0.0125 meters. Okay, so these are the values that are given, and to find the specific gravity of the oil is given. The specific gravity of oil is given as 0.95. So these are the details that are given to us. So the first thing that we need to find out is the dynamic viscosity of the oil. So we know that tau is going to be equal to mu times u by y. And we need to find out mu. So that is tau times y by u. We know the value of y and u, but not tau directly. Okay. So they have said each side of the plate. So the length of the plate is 0.6 meters. So if I can draw a picture like this, so this side is also 0.6 meters. Okay. So area is going to be 0.6 by 0.6. So which means it is 0.36 meters squared. Okay, so that is the area. And the force they have given that it is 98.1 newtons. So your tau is going to be F by A. So that is 98.1 divided by 0.36. So now if we substitute those values over here, so tau is 98.1 divided by 0.36. The value of y is 0.0125. The value of u is 2.5. So if we use the calculator over here, so it's 98.1 multiplied by 0.0125 whole divided by 0.36 and 2.5. So it is 1.36. So the answer here is 1.36 Newton second per meter squared. But they want the answer in poise, so simply multiply it by 10. So it is 13.6 poise. Okay, so that with that, we are able to get the solution for subdivision A. So the dynamic viscosity of oil is 13.6 poise. The next question is, they want us to find the kinematic viscosity. So let's do that in the next page. So the dynamic viscosity, we have found that it is 13.6 poise or 1.36 Newton second per meter squared. The other detail that we have is the specific gravity of oil is 0.95. So if you remember the definition, the specific gravity of oil is rho of oil divided by rho of the standard liquid, which happens to be water. So this rho of oil is what we need. The density of water is 1000 and specific gravity is 0.95. So rho of oil is 0.95 multiplied by 1000. So that makes it 950 kilogram per meter cube. So now the definition, the kinematic viscosity, which is represented by mu. So that is going to be equal to mu divided by rho. So that is 1.36 divided by 950. So let's use the calculator again. So 1.36 divided by 950 is 0.00143. 0.00143 meters squared per second, or I could write this as 1.43 into 10 to the power minus 3 meters squared per second. Okay, so that brings us this solution for the kinematic viscosity. So the subdivision A and B both are answered right now. The next problem is find the kinematic viscosity of oil having the density 981 kilogram per meter cube. Shear stress at a point in the oil is given and the velocity gradient. What is this velocity gradient? This velocity gradient is nothing but du by dy. Du by dy is directly given as 0.2 per second, which is second to the power minus 1. And they have given you the value of the shear stress, which is 0.2452 Newton per meter squared. So from these two, I will be able to get tau divided by du by dy, because tau is mu times du by dy. So this guy is going to be 0.2452 divided by 0.2. Okay, so there should be something like 0.12. Oh, it's not 0.12 because we have another point in the denominator. So it's going to be 1.226 Newton second per meter squared. So kinematic viscosity is mu divided by rho. So it is 1.226 divided by 981. So you'd be getting a value which will be meters squared per second. Okay. So if we calculate that, which is 1.226 divided by 981. So it is 0.00125. 0.00125, or you can write this as 1.25 into 10 to the power minus 3 meters squared per second. So that would give you the value of the kinematic viscosity. Okay, a very simple problem over here. Okay, we will stop here and continue in the next video lecture.